Okay, this first example, let's find the zeros of this equation. That means I want to find the x values that when y equals 0. So I'm going to plug 0 in for y. Okay, and then I'm thinking, how can I solve this? Well, I've got a trinomial. There's no common factors here, so let's factor this. So let's see, I could set up a diamond problem. I could put 4 on top and negative 12 on bottom. I'm adding to get 4, multiplying to get negative 12. So I need the same two numbers that will add to 4 multiplied to 12, negative 12. So let's see, 1 and 12 will be no good. 2 and 6 I could do something with if the 2 is negative and the 6 is positive, right? So that is going to factor like this. And then I can use the zero product property. One of these two products has to equal 0. So x would equal 2 or negative 6. All right, let's try it with this example. So again, I'm plugging in 0 for y, and then I'll try to factor the trinomial. Okay, and if I set this up, let's see, 4 up here and a negative 10 down here. Okay, so let me brainstorm the different ways I could multiply to get negative 10. Okay, I'm looking for one of these pairs. Those are the only 4 ways with integers to multiply to get negative 10. I'm looking for one of the pairs that will add up to 4, and it's just not happening. Uh-oh. So I guess no solution? Well, actually, there is a solution. There is something that x can equal, but we can't get there by factoring, okay? And so we're going to use completing the square. So I'm going to get back to this problem after I show you a little bit about completing the square, okay? All right, so I just wanted to show you why you'd want to complete the square when you can't factor. Factoring, I would try that first in general. When you can't factor, though, you might want to complete the square. Okay, all right, so let's solve this equation. So I'm taking the square root of both sides. And remember, when you take the square root of both sides of an equation, you're taking the positive and the negative root. Okay, so that's positive and negative 5. Think about it, negative 5 times negative 5 is 25. So either positive 5 or negative 5 will work. Okay, all right, so just a reminder on the positive and negative roots there. All right, a perfect square trinomial is, so you know, this is a trinomial. These are trinomials, quadratic trinomials. But a perfect square trinomial is one that's going to factor into something times itself. So in other words, something squared, right? Or you could write something times the same something, okay? So on this next problem, if I just factor this trinomial on the left side of the equation, let's try this out. Let's see if the left side will factor. Okay, so I'm adding to get 4, multiplying the same two numbers to get 16, and 4s will work, positive 4, okay? So, since this factors into something times itself, this is a perfect square trinomial. That's an example, okay? And you could write it like this. You could also write it as x plus 4 squared equals 49. And that's actually how I want to think of this, because what I'm going to do is I'm going to take the square root of both sides of the equation. I can do that because I've got something squared on the left, right? So if I take the square root of both sides here, on the left, I'm just going to get x plus 4. On the right, you got to remember, and this is important, it's not just 7, it's positive or negative 7. I'm taking, because, you know, I got this happening, right? So it's plus or minus 7. Okay, so sometimes I see students leave their answer like this. We're pretty close, but we're not there yet. We want to isolate x. So what I want to do is subtract 4 from both sides, okay? So, you know, you could write minus 4 at the end, but what I like to do is put the negative 4 in front of the plus or minus symbol. It's usually done that way, and it kind of makes more sense just thinking about it, because then I'm taking negative 4 and adding 7 or subtracting 7. Okay? I also see students leave their answer like this, but we want to go a little further. because we can simplify this more, okay? I've got negative 4 plus 7 will give me one possible answer, and then negative 4 minus 7 will give me another answer. And since these are like terms, then, you know, x would equal 3 if I'm adding the 7. If I'm subtracting the 7, I got negative 11, okay? So that's, yeah, I want to definitely simplify that all the way. Don't leave it like that or like that, okay? So this one was kind of a setup because the left side of the equation was already set up to be a perfect trinomial. And that same thing is going to happen on this next problem. So you could go ahead and try this one out, but we'd want to factor this first, okay? So if I factor this, I'm thinking, okay, negative 10 and 25. Here, let me separate this here. So adding to get negative 10, same two numbers, multiplying to get 25. Well, it's going to be double negative 5. So I could write it as x minus 5 times x minus 5, but I'm just going to write it as that squared because that's kind of the key with these completing the square problems, okay? So now I'm going to take the square root of both sides. Okay, whoops, I wrote 25 for some reason. I meant 27. Okay, so I got, now I want to isolate the x. So I'm going to add 5 to both sides, and I'm going to slip the 5 in front of the plus or minus like so. Okay, now this is pretty good, but we're not all the way there yet because we want to put our answers in simple radical form. Okay, so I'm going to break apart the 27. I know that's 3 times 9 is 27, so that would be 3 times 3 times 3, right? So then I've got a pair of twins. One of those will get out, one dies. So from the twins, a 3 gets out, and then I've got that leftover 3 that's just stuck in the jail, right? And so final answer, that's as good as I can do here. I mean, you could make a decimal approximation out of the 3 root 3 and then take 5 plus the decimal and 5 minus the decimal. But usually we're going to leave answers in simple radical form. So since these aren't like terms, I can't do anything more with that. Sometimes people will write, oh, this is going to be 8 root 3 because 5 plus 3 is 8. Well, that's incorrect because those aren't like terms. If I had 5 root 3 plus 3 root 3, then I could say it would be 8 root 3, but those aren't like terms, so you can't combine them, okay? All right, so we're getting back now to, this was the problem from the top of the page, okay? And so the trick, so just to, let me zoom out, we got kind of stuck up here because this wasn't factorable, okay? Now this is not a perfect square trinomial. If it was, it would factor into something times itself, but we know it's not going to do that because we hit a dead end with the diamond problem there, okay? So the key is I want to rearrange the right side of the equation so that it is a perfect square trinomial, okay? So here's how I'm going to go about doing that. So I want to move the 10 out of the way. Okay, so because I know that's not going to work for making a perfect square trinomial, so I'm going to move it to the other side of the equation. Okay, so now I have 10 equals x squared plus 4x. Okay, so on the right side, I don't have a perfect square trinomial, but I'm going to create one. And here's my strategy. X squared plus 4x plus something is going to give me a perfect square trinomial. And I can add whatever I want to the right side of the equation as long as I'm adding that same something to the left side of the equation. Okay? So I call this the mystery number. It's going to be the number that creates a perfect square trinomial. And that's just my own name for that, and you're not going to see that in that math book, but that's what I'm going to refer to it as. So this is the number that creates a perfect square trinomial. Okay, because if we have a perfect square trinomial, then we'll be able to factor it and take the square root of both sides, just like we did on these two problems. Okay, so there is a little formula for this. Okay, it's going to be b over 2 squared. Okay, and in this particular problem, my b, that's going to be the coefficient of the x term. That's going to be 4. Okay, so for this particular problem, I've got 4. I'm going to divide it by 2 and then square it. So 4 over 2 is 2. 2 squared is 4. So my mystery number for this problem is 4. I'm going to add a 4 to that side, and I got to make sure I add the same thing to the left side of the equation. Okay, so then I'm going to do the arithmetic on the left here. Okay, and on the right, I'm going to factor this. And it should factor, if I did this correctly, it should factor into something times itself. So let's try it out. Okay, I'm multiplying to get 4, adding the same two numbers to get 4. It's going to be double 2's, right? So this did work out. And now I'm in business like I was, here in that step on the previous problems. Next thing I'm going to do is take the square root of both sides to start to simplify this. Okay, so taking the square root of both sides here, don't forget it's positive and negative square root of 14. And that will just leave me with x plus 2. Okay, then I'm going to subtract 2 from both sides. Okay, and then I'd want to check the radical, but it's just 2 times 7. There's no twins there, so that's in simple radical form. So that one is done. Okay, so on to the next page. Just got some more examples of completing the square. So on these next ones, we're going to have to find the mystery number on all of these. So you want to use that formula, b over 2 squared, to find the mystery number. Okay, all right, so let's give this a shot. Okay, so you could try to factor this, but you're going to hit a dead end. Okay, so negative 7 is not the mystery number. So what I want to do is find what the real mystery number is. So I'm going to move the 7 over to the other side of the equation. And then since I'm going to be adding something there, I've got to add that same something over there. Okay? So I'll do my work up here. B over 2 squared. B here is going to be 2. So 1 squared is 1. So my mystery number is 1. Okay? And so this should factor now into a perfect square trinomial. Okay? So multiplying to get 1, it's either 1 times 1 or negative 1 times negative 1. And the positives are going to work out there. So this is going to factor into x plus 1 times itself. That means I've got a perfect square trinomial. Okay? On the right, I just did the arithmetic. And now I'm ready to take the square root of both sides. And the thing that the most common mistake that people make once they know how to do these problems is they just forget the plus or minus symbol when they take the square root of both sides. Okay? So I'm going to subtract 1. I'm going to slip the negative 1 in front of the plus or minus. And then I still want to put this in simple radical form. So I could break 8 up into 4 times 2. Or into 2 times 2 times 2, right? Then it's broken down all the way. Now I can see I got twins, so one of those will get out. And then I get the leftover 2 in there. There is my solution. Okay. Sometimes you might see it written out as 2 separate solutions, negative 1 plus 2 root 2 and negative 1 minus 2 root 2. I like to just write them like that all at once, but either way is fine. Okay, so let's try another here. So I'm going to move the 10 over to the other side to make space for the mystery number. So I'm subtracting 10 from both sides there, right? That's another thing I do is see people just move the 10 over and not change its sign. So make sure you don't do that. Okay, so b over 2 squared. B here is 6. So mystery number is 9. Okay, and then I'm going to factor over here. This is going to be x plus 3 times x plus 3, also known as x plus 3 squared. And then negative 10 plus 9 is negative 1. Okay. All right, let's take the square root of both sides. Hey, I've got the square root of a negative number. Okay, so hey, I'll move the 3 first. I'll subtract 3 first, but I don't want to leave my answer like that, right? Because the square root of -1 is I. So final answer I'm going to write as -3 plus or minus I. Okay, these completing the square is easier to do when the b is even, because we're going to be dividing it in half. So that's nice when I've got an even number that I'm dividing by 2. It doesn't work out quite so nice when I've got an odd b value like in these next two problems, but it still works. It's just I'm going to have to deal with some fractions along the way. Okay, so let's go through the process here. I'm going to add something here to get a perfect square trinomial. Okay. All right, so my mystery number, let's see. I'm doing b over 2 squared. B here is 3. Okay, so I can't simplify 3 halves, but I can think 3 halves times 3 halves would be 9 over 4. So really you're squaring the top and the bottom, right? So my mystery number is 9/4. And I don't like to use those kind of fractions, but I didn't leave myself enough space, so that's what I'm going to do here. Okay, so 9/4 is my mystery number. All right, zoom in there a little. Okay, so now I'm going to factor this, and this is a little weird to factor, but the key here, because we're usually using integers, right, for these factoring problems, but I know this is going to factor, if I did the mystery number correctly, this is going to factor into something times itself. So that's really helpful, okay? So I'm thinking, well, what times itself equals 9/4? Well, wait a second. I just did something times itself to get 9/4, right? So along the way, getting the mystery number, that will kind of reveal how to factor this. So this is going to be 3 halves and 3 halves. And if you think about that, you multiply them together, you do get 9 over 4. If you add them together, you would get 6 halves, which is 3. So it does work out, okay? So that's going to be 3 halves, okay? On the right side, I'm going to want a common denominator here, so I'm going to rewrite 1 as 4/4. Okay, and I'm gonna simplify this before I take the square root of both sides. I think it's easier to do it that way. So let's see, I've got 13/4, and now I can take, whoops, off screen. Now I can take the square root of both sides. Okay, all right, and then I've almost got x isolated. Okay, so I would actually honestly be okay with this answer, but we can simplify this more because you can write that radical as root 13 over root 4. So let's try that out. And then wait a second, the square root of 4 is just 2, right? And then wait a second, I've got a common denominator. So I can combine this all into one fraction. Like so, okay? So those are equivalent, and you know, we don't really have a radical in the denominator there, so I'm fine with that, but some books like to combine it into one fraction like so, okay? So next problem's similar to this last one because we've got an odd b, so you know we can run into those fractions. So you can pause it and try it out if you like. I'm going to get started on it. So I'm moving the 3 over. Okay, and then b over 2 squared. So let's see, b is 5. That would give me 25/4. And again, I didn't leave myself enough space here, so I'll go with those diagonal fraction bars. Okay, and then separate this. And then, let's see, I'm going to use a diamond problem here. Okay, what times itself is 25 fourths? Wait, let me go back on my work there. 5 halves times itself is 25 fourths. Okay, so, and that does work for adding up to 5 as well. So this is going to factor into x plus 5 halves squared. And on the right, I want a common denominator. So I'm thinking, okay, I already have 4 as a denominator over here. So why don't I multiply this by 4 over 4? Sorry, that got really small there. But that would be, 3 is the same as 12 divided by 4, right? 12 fourths. And now I'm good to go with combining those terms there. So that's going to be 37 fourths. Okay, take the square root of both sides. Okay, and again, I would be fine with this, but we can go farther by breaking up the radical. Oh, I'm not fine with that, sorry. I need to isolate the x. So I would be fine with this is what I meant to say. I'd be fine with this one, not the one above it. You got to isolate x for sure, okay? But then we can still play around with that, with the radical part there if we want to go further. And I'm going to end up with a common denominator. Oops. I'm going to end up with a common denominator there. So this would be -5 plus or minus root 37 all over 2. Okay? And that's fine as well. Either one of those would be good. And that's it. See you next time.